Okay, we are good to go. So it's late in the afternoon. It's late afternoon, early evening in Delaware. Jungeun's joining us from. Jungeun has a paper in the special issue of IGMEST, and you can access that via that email that I sent out the other day. So I will hand over to Jungeun. Welcome to Delta.
Hi, thanks for introducing me. My name is Jungeun Park from the University of Delaware in the United States, and today I'm gonna talk about my study titled "Bridging Student Informal Discourse and Formal Discourse on Limit." By the way, this is 7:09 p.m. in Delaware. So, motivation of my study comes from the fact that word in mathematics usually introduced with the definition. But then students usually have their own use of word on their own, and that usually creates conflict. For example, the definition of sequence that has limit L is introduced as for every epsilon positive, there is a corresponding integer capital N, such that a small n greater than capital N, then the error between A sub n and L is less than epsilon. But then when you ask students what the limit is, this is actually from our data, they say limit n approaches infinity A sub n equal to 5 means that the terms of sequence A sub n ultimately approach 5 as n increases. And this actually creates conflict because it actually has a different rules of, for example, classifying this given graph as an example of convergent sequence or not. So based on the formal definition, if this pattern continues, which I call dying sine graph, this is classified as an example of convergent sequence. But depending on who is looking at student's definition, this is not an example of convergent sequence because there are always terms that are moving away from 5, not approaching. Students can learn how to use those words according to the mathematical definition by looking at the professor carefully applying this definition on multiple examples and practicing on their own, or by developing their own definition towards a formal definition, and this is a setting that we are interested in. So the goal of our study is to investigate how students overcome such conflict between their initial discourse and formal discourse in their development of their thinking about the limit. And the format that we chose was reinvention of formal definition with instructor guidance. And we particularly was interested in student engagement of feature of their existing discourse. So to do that, we adopted cognition by SFAR 2008. And in cognition, mathematics is viewed as a type of discourse that has following characteristics. Use of words and then visual artifacts and then narratives that are endorsed as true in mathematics and the routines that explains actions of participants based on what they see as a task situation and then what they adopted the procedure to accomplish that task. Cognition views learning as a change in discourse in any of those characteristics that can happen at object level and multi-level. So object level learning is expanding discursive characteristics of existing objects. And it is usually self-motivated by students because students can apply, for example, definition or theorem that they learned on a whole bunch of examples to increase their repertoire of that application of theorem or definition. But in meta-level learning, changes happens in meta level. So it involves changing the meta rules of the discourse regarding those features. And those include something like rules about defining. So for example, the definition should be operable. So any object should be classified as examples or non-examples, and definition should be invariant under changes of representations. And those are not necessarily natural extension of student discourse. And those meta rules are historically established by practice. So it's not necessarily something that students can come up with on their own. So it has to be guided by an expert, for example, teachers in the classroom. In relation to learning, teaching is defined as any communicational activities, the motive of which to bring the learner's discourse closer to formal discourse. In the recent literature, they started talking about something called interdiscursivity to promote such learning, meta-level learning. And they suggested using student existing discourse in meta-level learning, although it is not a natural expansion of it. So they suggested using providing tasks to students in which they can use features of their old discourse, but in emerging ways that are appropriate in the eyes of teachers. So it has component of student discourse, but at the same time, the instructor practice is informed by formal discourse. And officially, the interdiscursivity is defined as a blending of discursive elements from the different discourse, as in our case, student discourse and formal discourse, as a mechanism for designing task situations to support learners in taking their first step in emerging discourse. So this task situation, in our context, was chosen as guided reinvention, which is instructor approach in which students learn about mathematical objects with the two components. First component being student-owned the process. So a process by which students formalize their informal understanding and intuitions based on their own experience and activities, but with carefully designed instructor guidance. So it has the component of student discourse, but also the instructor guidance is informed by formal discourse. So in our study, the guided reinvention teaching experiment was designed and implemented by an experienced instructor in the second semester of calculus sequence. And we had 11 students in class, and we made 3 groups. And we did it over 5 class period time. And we video recorded 4 students in teacher experiment group we called TE group, and the whole class discussion. And we transcribed our data and then collected their written work and digitized them. So during teaching experiment, students were first asked to generate examples and non-example graphs of sequence converging to 5 based on their existing discourse. But then instructor implicitly, meaning that he did it outside the classroom, so student didn't see, implicitly endorsed them as examples and non-examples and chose some of them to display in front of class. By the way, all the examples or non-examples and students were created was deemed correct. So there was no something wrong with their examples and non-examples. So that was informed by formal discourse because instructor used his judgment to decide whether they did it right or wrong. And then they discussed their convergent and non-convergent behaviors. And they worked in small groups to define a limit of sequence through what we called iterative refinement process. So they wrote a definition based on their own thinking, but then they evaluated definition against examples and non-examples that was informed by formal discourse, especially the meta rules of defining, because all the definitions should include examples. Definition should include all the examples and exclude all the non-examples. And then students acknowledge if there is any problem with it. And then they come up with a solution and they reflect it to revise the definition, and then they go through the cycle again. So in our TE group created a 23 group definitions we numbered through, which we numbered from 1 through 23. So these are examples and non-examples that student came up with and approved by instructor. And in this talk, I'm gonna use example B, the dying sign graph that we talked about, and example G, which is increasing and then decreasing to the limit, and then non-example 1, which is increasing but has 4 as the limit. So our analysis starts when students realize the conflict, that their definition includes non-examples and excludes some of the examples against their intention. And after they exhausted all their object level attempts, instructor guidance started, which was actually help them move towards the formal discourse about the limit, but still using the features of their existing discourse. And then we made two main observations about interdiscursivity from our data. So first observation was student definition moving from descriptive words to quantities. So I mentioned before, student initial definition uses this descriptive terms, for example, ultimately approach. And then students realize the problem because this non-example 1 that has limit 4, actually the terms ultimately approach 5. And then for the reasons that we discussed, this dying sign graph, which meant to be an example, is not an example. It actually is excluded from the definition. So they attempted first the distance between the terms of a sub n and 5, which they also called error and written as this absolute value, as in definition 3. And then they used that phrase with ultimately decreasing, so that ultimately survived. And the second attempt was error bound. And their error bound was slightly different from how we use in mathematics. And they called error bound and then used epsilon for as a distance between two consecutive terms. So one above the limit, one below the limit. So they decided this isn't working because some of the graphs don't even have error bound. So this is not applicable for all the examples and non-examples. But this ultimately approach still survived in definition 5. So the ultimately was consistently used in their definitions from 1 through 5. And then when instructor asked what it meant, they actually differentiated the terms of the sequence after some point from the terms before that point. For example, student 3 said initially it could go away from 5, but at some point it starts moving towards 5 and doesn't stop after that. And their interdiscursive engagement with that word ultimately starts from instructor asking to illustrate ultimately on graphs. He asked, in G, what's this ultimately? So he's using student word ultimately. And student 2 said because it starts out not approaching, so basically she repeated the justification for ultimately, and the instructor asked again, yeah, can you get specific? What counts 1, 2, 3, 4, 5, what's this ultimately? Here, he's using ultimately, which is obviously adverb, just like noun. So the object in mathematics, which is usually realized as noun or noun phrases or symbols. And student 3 responded, it approaches from A1, A2, but then from A3 to 4, 5, 6, it's going away from 5. And then one said, it be 6 on, and that's when instructor agreed by repeating it. 6 on, is that what you think ultimately was getting at? Because I was looking at this, wondering what it was. And here, he's approving it from the formal discourse perspective because the target discourse defines limit using quantities and their relations, not descriptive word like ultimately. And then he pushes them a little more. On G, you are acting like ultimately stood for something. Where is that? I'm looking for you illustrating this definition, not just talking about it, but illustrating some of the things here on graphs. So he's actually promoting student existing routine of illustrating what is written. And this is also informed by meta rules in the formal discourse, which is the definition should be invariant under the change of representations. And after this, they worked on it a little bit, and then they actually draw ultimately with this green arrow. Point here, ultimately saying, we could say that ultimately takes into account everything from here on. So after this exchange, they actually revised their definition. And they introduced a specific value n such that a sub n for all n's after that is so close to 5 that is basically equal to 5. And then their justification of adding these phrases were similar to the justification that they gave for ultimately to accommodate the initial and undesirable behavior of G moving away. So specifically, the student 2 said this specific and allows them skip all the fluff and get to it. The second, The second result that our second result is the student moving from realizing all these quantities towards relating the quantities. So this happens in day 4, 5. So there were a lot happening between day 2 and 4, but we are focusing on where we observed interdiscursivity. So in the beginning of day 4, the teaching experiment group had this group definition. If the error is less than epsilon for any value n, and n is greater than n sub c with error goes to 0, then a sub n converges to 5. So one may say it contains all the crucial elements in a formal definition, but as you can see, it doesn't explicitly explain the relation among a sub the error bound, and n sub c. And when they were asked to illustrate their definition on multiple graphs, example graphs and non-example graphs, they were doing the same routine. And then 2 were identified. First, they draw epsilon first with the 2 bounding lines. And then they identified n sub c as the last n after which all terms are within those 2 lines. And their interdiscursive engagement started with how they chose n sub c. An instructor asked if their definition captures their choice of n sub c by saying, you've illustrated some stuff and keep saying there is this n sub c, and then you said all terms, and he asks, this second term couldn't be n sub c because you said, and here, instructor is using student illustrating routines, and one responded as because all terms after aren't within those 2 lines. And then instructor asked again, do you think this definition captures that idea? Again, this was informed by formal discourse because it was the meta rules of the defining, which is definition should be invariant under the change of representation. In this case, written and illustrated. And one said, we should probably add that though, all terms after it, and they actually added it in their revision of definition. So they said all terms after n sub c are within the given error bound. And here, students are using their existing routine of finding the written form of what is illustrated. And then students' interdiscursive engagement with them drawing epsilon first started with instructor asking if their definition captures that. So instructor just straight out asked, what did you always draw first? And here he's again mentioning student illustrating routines. And then one said, oh, error bound. And then instructor said, do you feel like your definition captures that? You are saying, well, this is what our definition is doing. If I were to give it to somebody else, do you feel like you've explained it in a way that captures what you just illustrated? So here, this is again informed by the meta rules in the formal discourse, which is the definition should be invariant under the change of representations. And then one said, probably not. We didn't really define what error bound is. And then instructor asked one more time. So try to make it readable for somebody that's never seen it before, but they could understand it. So this prompt is informed by meta rules of formal discourse, which is the definition should make sense to everyone. And after this exchange, they switch it, they try to put epsilon first in the written form just by quickly changing the order in the inequality. But then this definition was read by other groups of students. And then they found their use of inequality as problem and suggested starting with their definition within a necessary given error bound and then reorganize a sentence. And then they did. And then they said within a given error bound for a sub n, there is an n sub c such that if n is greater than n sub c, then error is less than the given error bound. And here they are again using existing routine of finding the written form of what is illustrated. So our results shows extended use of student routines in their existing discourse, in this case, illustrating written expression on graphs or finding the written expression of what is illustrated, which is also aligned with the meta rules of formal discourse. The definition should be invariant under the change of representations. And those extended use of routine help them finally resolve the conflict from their initial use of descriptive word approach. And this was possible through our design of guided reinvention, where first student created examples and non-examples based on their existing thinking. And then, which was approved and chosen by instructor from the formal discourse perspective, and students generated their own definitions based on their own thinking, but they were guided to include all the examples and exclude all the non-examples, which is governed by meta rules of defining in the formal discourse. So our results shows how meta level learning, which is the learning of new discourse, not a natural extension of their existing discourse, may also introduce conflict, can be promoted using interdiscursivity, which is using the element of student existing discourse through instructor's guidance informed by formal discourse. And our results also highlight the importance of instructor roles. So instructors' timely realization of features of student existing discourse was crucial, especially when it has meaning in the context of emerging discourse. And also instructor envisioning the activities in which students can engage with those features in their development of formal discourse was also crucial in our setting. All right, so that's it. Thank you. I would appreciate any questions or comments.
Thank you, Jungeun, for your presentation. Are there any questions in the room? Anybody would like to share a comment or something? We have maybe time for one question, comment. Anybody? There's a question over here by Tracy.
Given that the speaker is not present in the room and hence can't see the appreciation, I just wanted to say that I thought that was absolutely brilliant, and I'm going to try and use some of these principles in my classroom. Thank you very much. It was super interesting.
Okay, thank you so much. I appreciate so much. I mean, I'm happy to talk to you about any use of this framework. Yeah.
Thank you. And there's just another comment from Greg.
Yes, it's also a comment, Jungeun, because as the editor of the IGMest, I've of course read your paper. I think I've probably read it through maybe 3-4 times as it's gone through its feedback and loop. So thanks very much for the wonderful paper and contribution to the journal with the 13 others. And I acknowledged this morning that IGMest is very, very great, or very, very appreciative of the work of the papers that contribute to Delta and your paper. Again, we really value the fact that you've put this paper into this proceedings. So thank you, Jungeun.
Okay, all right, thank you.
Thank you.